Lesson 10-5. Apply other angle relationships in circles. By the end of today's lesson, we'll be able to successfully find the measures of angles inside or outside a circle. First of all, just like the previous lessons, we're going to first focus on the theorems and what they entail, and we're going to also learn how to use them. And in class, I will focus more on the proofs. So in Theorem 10.11, if a tangent and a chord intersect at a point on a circle, so a tangent line A intersect with a chord at a point on the circle, then the measure of each angle, 1 and 2, formed is 1/2 the measure of its intercepted arc. So measure angle 1 here will equal to half the measure of arc AB, and measure angle 2 will be equal to half the measure of arc BCA. So this is very similar to the theorem in which you have an inscribed angle and you want to find the angle measure of the inscribed angle, which is equal to half the corresponding intercepted arc. So example 1, to apply this theorem, line M is tangent to the circle. Find the indicated measure. So measure angle 1 would just be equal to half times the measure of the intercepted arc, which is 132 degrees. And half of 132 degrees is just 66 degrees. So that would be your answer. And for part B, we would like to find the measure of arc EFD. And by using the formula, since we know the angle measure, 110 degrees, then we could do this. All I have to do is double 110 degrees, which is 220 degrees. Theorem 10.12. Angles inside a circle theorem. If two chords intersect inside a circle, such as BD and AC, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So what do I mean by this? If we take a look at measure angle 1, according to this theorem, to find the measure of angle 1, it will be equal to half times the sum of measure arc DC plus measure arc AC. So DC will be one of the intercepted arcs and the vertical angle. And angle 2 will be equal to half times the sum of the measures of arc BC and arc AD. Theorem 10.13. Angles outside of a circle theorem. Of a tangent and a secant. So tangent and a secant, or two tangents, or two secants. Intersect outside a circle. So they intersect at the point outside of a circle. Then the measure of the angle formed, meaning these angles, is 1/2 the difference of the measures of the intercepted arcs. So for measure angle 1, it will be 1/2 the difference of the measure of arc BC minus the measure of arc AC. And measure angle 2 will be equal to half the difference of measure angle arc PQR minus the measure of arc PR. And measure angle 3 will be 1/2 the difference of measure in arc XY minus measure arc WZ. Example 2. Find the value of x. So in this case, we need to apply theorem 10.12. Since we know the measure of arc GH and measure of arc FJ, I can just go ahead and do x degrees equals to half the sum of 140 degrees plus 112 degrees. And this would be equal to 126. In part B, we will have to use theorem 10.13, where we have a secant intersecting a tangent. So to find the measure of angle x, we'll do half times the outer intercepted arc, which is 170 degrees, minus the inside intercepted arc of 72 degrees. And this would be half times, so 170 minus 72 give you 98, and then we'll have to divide by 2, which is 49. Example 3. You're flying in an airplane about 5 miles above the ground. What is the measure of arc BD, the part of Earth that you can see? I need to use theorem 10.13 to find this arc length. So I will need to know measure angle BCD. And this will be equal to half the measure of arc BED minus the measure of arc BD. Now, I don't have enough information to use this formula yet, so I need to find some angle measures. I believe I can find the angle measure of BCD. But before I find the total angle measure, I would like to find the angle measure of ACD, because I have enough information to determine that. First of all, I know BC and CD are tangent to Earth and they form right angles with the radius. And to find this angle, I can use sine. So I'm going to write measure angle ACD is equal to inverse of sine. And I know this length is 4,000, and this length would be 4,000 plus 5 as given in the problem. So that would be opposite over hypotenuse, 4,000 over 4,005. And we use your calculator, you should get about 87.1 to the nearest tenths. And then measure angle BCD will be twice 87.1, which is 174.2 degrees. So now I have measure angle BCD, and then I can let measure of arc BD be Y and arc BED be 360 degrees minus Y. And now I can use the formula and solve for Y. which is approximately 5.8 degrees. So again, this will be the measure of arc BD. Example 4. Find the indicated measure or the value of the variable. So this is just another quick practice of applying all the theorems that we've just covered so far. And for part A, we want to find the measure of arc ACB. In this case, we need to apply the theorem 10.11. So again, you would just have to take 120 degrees and multiply by 2, because this angle here is half of the measure of arc ACB. So this will be 240 degrees. And for part B, we'll have to apply theorem 10.12. And we're given this angle here to be 52 degrees. So this angle should be 128 degrees by the linear pair postulate. And now we can apply the theorem. So 128 degrees equals half. And we're given one of the arc lengths, 144 degrees, and we want to find the other one. So that would be x. And then we can go ahead and solve for x. So, let's be 112. Part C, we will have to apply theorem 10.13 since we have two secants intersecting at a point outside of the circle. And we're given the angle measure here, as well as one of the arc lengths, the one inside. So we want to find the one outside. So we can do this. 26 degrees equals half, and then y minus 30 degrees, because we want the outer intercepted arc first. So I can first multiply both sides of this equation by 2. So y will equal to 82 degrees. Okay, part D is very similar to example 3. Now, we're given that this little length here is 2 and the radius is 4, so this entire length CE is 6. Okay, so we want to find the outer intercepted arc. And we still need to use theorem 10.13. But first of all, we need to first find the angle measure of DCA. But before we do that, we could first find the angle measure of DCE by using inverse of sine. So measure angle DCE would be equal to the inverse of sine. If we look at this angle here, opposite over hypotenuse, 4/6. And this would be equal to about 41.8 degrees. You can just use your calculator. And then measure angle DCA will be equal to twice 41.8 degrees, which would equal to 83.6 degrees. And now we can apply the formula. Since we know this angle measure, then we could do that. Half A minus, and we could let this arc represent 360 degrees, subtract A. So simplify. So A would be approximately 263.6 degrees.